Hello everyone, this is Sir Aris. Today let us talk about lines and planes. So we will be using our knowledge in vectors to determine equations of lines and planes. In analytic geometry, a point is a set of three coordinates x, y, and z. We think of this point as the head of a vector r with components x, y, z, and this unit vectors I, j, k, with a tail at the origin, just like here in the figure. This is the tail, the head is over here. So x, y, z, uh, and the vector r will be the same in our case. Um, we shall use vectors in joining 2 points. For example, if you want to join this point 1, 2, 3, and x, y, z, call it vector A. Um, in our two vector notations here as um, coordinates xyz, or as uh, sum of the unit vectors along xy and z direction. We can also write this a here as the difference r minus c, where c is this point over here. So if you take r, or if you take c plus a, that would be r, which means that if you want to get a, then it would be r minus c, or we write here as if r is xyz and c is 1, 2, 3, we simply subtract to get x minus 1, y minus 2, z minus 3. Or alternatively, you can also write a as um, ix plus jy plus kz minus this 1, 2, 3 here to be written as 1 I plus 2j plus 3k, or this is x minus 1 I plus y minus 2j plus z minus 3k. Now, in two dimensions, we write the equations of a straight line like this. We have um, a variable y and x, so any point y and x. If the line passes through this y and x and this point x, not y not with slope m, we write the equation of the line like this. Suppose we are given a vector, let's say the vector a, and we want to determine the equation of a line passing through this vector a. Suppose we have a given point here x naught y naught and this arbitrary point xy. Using these two, let's say the arbitrary point is right here, we can get this r minus r naught vector, that's this expression. So if this vector is parallel to a, they are in fact on the same line in this figure. So if two vectors are parallel, it means that the components are proportional, just like here. So if you write here uh like, like this, y minus y naught divided by x minus x naught and b over a, this is similar to our equation of the line here with slope b over a. In three dimensions, it would just be the same. We can determine a straight equations of a straight line through this point parallel to this vector. Um, let's say our xyz is the arbitrary point. This joins with this and is parallel to a. In that case, we have this. We call this the symmetric equations of a straight line with a, b, and c not zero. If ever one of them is zero, say c equals zero, we just set that the corresponding uh, component or elements of the cor- or component corresponding to that variable here that is 0, set them equal, and then we have this expression. In a plane, if you have x naught, y naught, z naught, a given point in the plane, and x, y, z another point, you can connect the two. That would be r minus r naught. If n is perpendicular, we take the dot product of n dot r minus r naught. It should be 0 if they are perpendicular. So we get this expression. This is our equation for the plane. Um, Simplifying, you can write ax by cz equals d here. So generally, you can use this um, coefficients a, b, and c as um, coordinates of a vector perpendicular to this plane. So an example, find the equation of the plane through the 3 points a minus 1, 1, 1, 2, 3, 0, and 0, 1, minus 3. So let's introduce a notation first. So the line that connects A to B, let's call that AB with an arrow on top, or that's B minus A. So AB would be 2, 3, 0 minus negative 1, 1, 1. That's 2 minus negative 1 would be 3. 3 minus 1 is 2. 0 minus 1 is negative 1. Also, if you want to connect A and C, that would be 0, 1, minus 2 minus negative 1, 1, 1, or 1, um, 0, and minus 3. The cross product of these two is perpendicular to the plane. Let's call it n. So n is a vector perpendicular to the plane. So it uh, one vector that's perpendicular to the plane is the product of these two, cross product. AB cross AC. So take the cross product IJK. AB has coordinates 3, 2, minus 1. You have here 1, 0, minus 3. Okay, so we take I, 2 minus 3, that's minus 6I. Okay, for J, you have 3 times 3, that's negative 9, minus negative 1, so that's negative 8. But this has a cofactor negative, so it's positive 8J. And for K, 3, 0, negative 2K. So this is perpendicular to the plane. We want to get the equation on the plane. So the equation of the plane, the equation of the plane with normal or perpendicular uh, to n. So normal direction n through passing through, for example, B, or we can choose A, B, or C. Let's choose B. So we can write it as, so the normal has this um, co coordinates or components. We take that product with this B, and the answer should be 0, or a line passing through XYZ. So XYZ like here, and B. So we connect x, y, z, and b. So that would be, so if we use our formula, ax minus x naught plus by minus y naught plus c z minus z naught equals 0. Our a is minus 6, b is 8, c is minus 2. So you have x minus, we're choosing b, which has coordinates 2, 3, 0. So we have 2, 3, 0. So z, um, y, and minus 2, or let's say plus this. We divide both sides by negative 2. You get here 3x. This becomes negative 4y, and this becomes z. Um, the others become, you have this is 3 times negative 2, that's negative 6, plus negative 4 times negative 3, that's 12. So this is plus 6. This is the formula for the equation of that plane. So find the equations of a line through this and perpendicular to the plane in the previous example. So in the previous example, n equals minus 6i plus 8j minus 2k is perpendicular to the plane in the previous example. So the symmetric equation or equations of the line are following. So you have x minus 1 over minus 6, you have here minus 6, equals y minus 0 divided by 8, z minus negative 2 over minus 2. So this equation, we can multiply both all of them by 2 or negative 2. So we can write it as x minus 1, 3, y over negative 4, z plus 2 over 1. Another example, find the distance from the point P 1 minus 2, 3 to the plane 3x minus 2y plus z equals 1. So the equation of the plane is this, which means that n equals 3i minus 2j plus k is perpendicular to the plane. Here, if we take the magnitude, that's 3 squared plus negative 2 squared plus 1 squared, that's square root of 14. This allows us to get the unit vector directed towards n. Let's call it n, or n hat. It's n over n magnitude, so that's 1 over square root of 14, 3i minus 2j plus k. Okay, this is a unit vector perpendicular. So this is perpendicular to the plane. So you want this because if you want to create a plot, say this is a plot for the plane. So that's the plane. Um, Suppose this is our point P. So relative to this plane, we just want to determine this perpendicular distance. Um, what we are doing is, so we know a unit vector perpendicular to the plane. We don't know its direction. It could be up here or downward, doesn't matter. as long as it's perpendicular. We can find an or a random point here. Let's say let's call that Q. So we can connect P and Q. Okay. So say PQ are connected, or let's say that is QP. Okay. That QP, we then take we then project along this n direction by a dot product that would then give us this distance. Okay. So what we need is this Q that could be any random point. Suppose we choose x equals 0, y equals 0. In this case, if x is 0, y is 0, so you have 3x minus 2y plus z plus 1 equals 0. So this is 0, 0. It means that z equals negative 1. So q equals 0, 0, minus 1. Pq is 0, 0, minus 1 minus 1 minus 2, 3. And that would be negative 1, um, 2, and negative 4. So if we take the dot product, which is the distance, so pq dot n, and to make sure that we are getting the distance, we take the amplitude or the magnitude. So this becomes um, not only magnitude but the absolute value. So this is the absolute value of um, PQ is this, and this is the um, unit vector. So that's 1 over square root of 14 minus 1 times 3, that's negative 3. 2 and minus 2, that's negative 4. Minus 4 and plus 1, that's negative 4. So that be negative 3 plus negative 4, that's 7 minus 4, or negative 7 minus 4, that's negative 11. So the final answer would be 11 over square root of 14. This is the distance from P to the plane. Final example, find the distance from 1 to minus 1, the line joining P1 and P2. Suppose, let's say this is not to scale. This is randomly set as it's just a random direction. So let's say this is P1 and P2, and this is P. We want to get this distance. Let's call this distance PR. Okay, we can first find, we can connect this. So that's P1, P2. Let's call that vector A. Once we have A, we can then connect P and P1. Okay, now that P and P1 and A, if you take the cross product, it will be the projection of, so the angle between the two is this. It will be the projection of P, P1 on this direction, on this line, giving us this PR. So basically, PR is just the absolute value of PP1 cross, um, it would be best to get the unit vector for A. So that's A over A magnitude. Okay, so what is A? In this case, A is simply, so P1, P2 connected. So we start with P2. You have negative 1, um, 0, 2, minus 0. So that's negative I plus 2k. So the magnitude A over a magnitude would be negative I plus 2k divided by magnitude is 1 squared plus 2 squared, that's square root of 5. That's it. How about p to p1? P to p1, so we write p1 first as 0, 0, 0, minus p is 1, 2, minus 1. So this is negative 1, negative 2, and 1. Or negative I minus 2j plus k. Okay, so taking the cross product p1 cross a unit vector, that be I j k, um, negative 1, negative 2, 1, and this one with the 1 over square root of 5. So let's factor out 1 over square root of 5. So you have negative 1, 0, 2 times 1 over square root of 5. This would be 1 over square root of 5 I. So you have 2 and 2. So this becomes 4I. Okay, actually negative 2 times 2. For j, you have minus 1 times 2. So negative 2 minus negative 1. So that would be plus 1, so negative 1 times negative, this is plus j. And then k, k would be, so you have minus negative 2 times negative 1, so that's positive 2. Negative of that, so this is negative 2k. Okay, now we're getting the absolute value p1 cross a absolute value, that would be our PR. But let me do this first. So this is 1 over square root of 5. This is 4 squared, that's 16, plus 1 plus 4. Take the square root, that would be 21, or 21 over 5. Take the square root. This is just our PR, the distance between point P to the line connecting P1, P2.